In this video, we're going to talk about some solution stoichiometry. Now, you may recall from our last video where we talked about some different types of solution concentrations and some calculations that you can do with solution concentrations and dilutions. In this video, we're going to talk about how to use that data and use that calculation of concentration, in particular molarity concentration, moles of solute per liters of solution, to solve common solution-based problems that would be found in stoichiometry, especially if we're dealing with solutions and chemical reactions that are occurring in aqueous solution. So you may remember from our discussions in chapter 7 the idea of a mole map, the idea that we can take particles or grams of substance, and so long as we convert it into moles of that substance, and then using our balanced chemical equation, we can convert moles of that one substance into moles of another substance using that balanced equation ratio. And then we can turn it in the moles of the other substance into whatever we want, usually grams. But what we can do now is we can see that with molarity and volume, we can use molarity and volume of a solution to determine the number of moles of solute of that solution, of that substance, and plug it into our calculations just in the same way that we did before, keeping in mind that molarity, M, capital M, is equal to the moles of solute divided by the liters of solution. And so long as we can keep that in mind and have that ratio kind of at our fingertips, this relationship will allow us to go between volumes of our solution and moles of our solute that is dissolved in that solution. So let's take a look at a couple of examples. So for example, what is the mass of sodium hydroxide that I would need to precipitate cadmium 2+ ions from a 35 milliliter 0.5 molar cadmium nitrate solution? Okay, a lot of stuff going on here, but we can kind of get to the heart of it immediately. I've got cadmium 2+ reacting with hydroxide to make cadmium hydroxide, which would be a solid precipitate. So there's my balanced chemical equation, which is what I need for any stoichiometry calculation. Now, what do I do with the rest of the information here? Well, if I think back to that idea of that mole map, I know that I need to convert something into moles. And so what I can look at is, okay, I have volume of cadmium nitrate that I can turn into moles of cadmium nitrate, which I can then turn into moles of NaOH, and then turn that into grams of NaOH. So you may be looking at this and saying, okay, well, that's not quite the same thing. How can I go about fixing this and making it so that it is matching the molecular instead of this net ionic? Well, if I take it from here, I've got my cadmium nitrate, and I'm adding to that my 2 sodium hydroxides, and I get cadmium hydroxide, which is a solid, and the other product here would be sodium nitrate, So here's my balanced molecular equation out of that net ionic equation. And now I can see I've got the fundamentals here that I need to solve the problem. I've got my volume of cadmium nitrate. I've got a concentration, so the volume goes there. The concentration is what I'll use in this step to convert that volume to moles. And then I've got my balanced chemical equation to do the moles. And I just need a molar mass of sodium hydroxide for the last part here. And we can calculate that pretty simply. 22.99 grams for sodium plus 16.00 grams for oxygen and 1.01 grams for hydrogen. We get a molar mass of 40.00 grams per mole for that part right there. And so now I've got all the things that I need to do the conversion and to do it properly. So my first step is I've got 35 milliliters of cadmium nitrate. Now, a couple of ways that you can go about doing this. I tend to prefer just to do kind of the straightforward approach. Let's do the full conversion using dimensional analysis. How I can use dimensional analysis is again keeping in mind my definitions. 0.5 molar means that I have 0.500 moles of cadmium nitrate in every liter of solution. And so since I have that definition in mind, remember any definition I can flip around the equation as I see need to do my dimensional analysis conversion. And so if I go from that standpoint, 1,000 milliliters in 1 liter, 1 liter of solution contains 0.500 moles of cadmium nitrate. And now I've got my moles of cadmium nitrate. I've completed the first step. The second step is to use the balanced chemical equation. I need to convert my moles of cadmium nitrate. The coefficient here is 1, so 1 mole of cadmium nitrate for every 2 moles of sodium hydroxide. And then my last step is to convert the moles of sodium hydroxide, 1 mole of sodium hydroxide, into grams, 40.00 grams. And so with that last step in tow, I've completed all of my fractions. I've got everything ready to roll. Equals, let's do the calculation, 35.0 multiplied by 0.5 multiplied by 2 multiplied by 40 divided by 1,000 and then divided by a series of 1s, so we'll just ignore those steps. I get to 3 significant figures, 1.40 grams of sodium hydroxide. Double check myself, make sure that everything's good and on the up and up. Milliliters cancel, liters cancel. My moles of cadmium nitrate cancel. My moles of sodium hydroxide cancel. I have grams of sodium hydroxide left. The reason why this doesn't seem to mix up is because this isn't actually cadmium nitrate, it's cadmium nitrate solution. And so with that appropriate label on it, My solutions cancel as well. I'm left with just grams of sodium hydroxide, and that's my final answer. Let's look at one more example here, kind of taking the concept and flipping it on its head here. What volume of 0.115 perchloric acid solution is needed to neutralize 50 grams of solid calcium hydroxide? So the setup here is incredibly similar to the one that we just did previously. I've got calcium hydroxide, reacting with perchloric acid, and I'm going to go ahead and throw in the correct coefficients there. And this is a double replacement reaction, so I'm going to have calcium perchlorate and water as my products. So there's my balanced chemical equation. The process here is slightly different. I'm actually going to start with 50 grams of calcium hydroxide, but I'm going to turn that into moles of calcium hydroxide, turn that into moles of perchloric acid, and then turn that into volume of perchloric acid. And so the steps here, remarkably similar, as I said before. I'm going to need a molar mass to do the first step. I'm going to need the balanced chemical equation to do this step here in the middle. And then I'm going to need this molarity to go between moles and volume. The only thing that we're missing is the molar mass. Molar mass, 40.08 for calcium, plus 16 for oxygen, and there are 2 of them, and 1.01 for each hydrogen, and there are 2 of those. Total mass, 74.10 grams. Per mole for calcium hydroxide. So take a minute, try to work this out on your own, and then skip ahead about 10 seconds in the video, and you will see I'll give you the completed workup here. So if you don't want to see the final answer until the very end, go ahead and hit pause right now. Five, 4, 3, 2, 1. All right, here's our setup. If you follow the mole map and kind of the steps that we were doing, this is where you should land at the end of the process. Now, to figure out the answer, we're going to take our 50.00, multiply that by 2, divided by 74.10, divided by 0.115, and what we get is a rather large number. So to 3 significant figures, again 3 because of our concentration here only having 3 sig figs, this would take an incredibly large amount of acid, 11.7 liters of HClO4 solution at this particular concentration. Now, if this number were not so large, if this was a decimal number, it would be pretty common to see this number multiplied by 1,000 to get into milliliters. However, that's really not necessary in this particular case. So this is solution-based stoichiometry. In the next video, I'm going to show you what to do when you have a titration. That is, both of your reactants are liquids and solutions. How do you handle that situation? Might actually surprise you. Have a good day.